Today we are going to understand how the probe size is selected in ultrasonic testing. Okay, before going to understand this, we understand the concept of near field. Okay, this is a ultrasonic probe, if you assume, and while releasing the ultrasonic beam, it is of this nature. Okay, this is of this nature. This is the convergent part, and from here it is divergent part, right? And this convergent part is called near field. Divergent part is called far field. You understand? This is the far field. See, in this near field zone there is some peculiarity. The peculiarity is that, you see, this is a 5 MHz probe. It is releasing the ultrasonic waves. You see, up to this part it is the near field zone, and from here it is the far field zone. Okay, you see, the intensity along the direction of the wave is varying in the near field zone. See, this is of lesser, this is of more, this is more, this is again less, and also axially the intensity is varying, and also in the at the same point it is varying. Axially also it is varying, and at this same point it is varying. So for us to find a defect in this zone is very difficult because the intensity is irregularly varying. Okay, now we'll understand this one. The third thing to decide while selecting a probe is the probe size. Okay, what is the third thing? What are the other two things? One is the beam direction, the probe frequency, and the beam size. We are discussing this one. These two will be decided in the other videos. Okay, for a given frequency, the near field length depends only on the diameter of the probe. This is the near field length formula. It depends only on the diameter. That is d square by 4 lambda equals d square f by 4v. For a given material, velocity is constant, right? If we are holding the frequency constant, it is same, and changing the diameter of the probe, the near field is increasing if diameter is increasing. Okay, and as the sizing, okay, depends only on the diameter of the probe. You understand, right? Near field depends only on the diameter of the probe, and as the sizing of glass in most cases is done on the basis of comparison with some reference reflectors. Okay, so normally in UT the sizing will be done based on the comparison between the reference reflectors. Okay, the near field should be as short as possible. Why it should be as short as possible? This is because the intensity variations along and across the ultrasonic beam. Along means along and also across, right? Along and across the ultrasonic beam axis are irregular, and sizing of loss occurring in the near field cannot be done by comparison of its reflectivity to the reflectivity of a reference reflector. Okay, thus for a given frequency, the probe diameter should be as small as possible to have a shorter near field. You understand? I will simply brief it again. You see, first the concept of near field. What is near field? For a beam, it will be first convergent and divergent, right? So in this convergent field, along the axis the intensity is irregularly varying, and across the axis also the intensity is irregularly varying. So if we are getting any defect in this region, we can't size it accurately. So for us, this zone should be as small as possible. If this should be as small as possible, near zone should be as small as possible. That means diameter should be as small as possible. Simple. So use the smaller length probe. Understand? Please subscribe, guys.